So in this class I want to look at finding probabilities for experiments involving a single task. So just a single task here. The most important thing in probability is this equation, which says the probability of any event E taking place is the number of ways in which that event may occur divided by the total number of possible outcomes. You have got to learn that by heart. And everything in probability comes out of understanding that equation. So you've got to know that. The number of ways an event may occur divided by the total number of possible outcomes. So a fair six-sided die is rolled. I want to list the sample space. We mentioned before that the sample space for an experiment is a set containing all possible outcomes. If I roll a fair six-sided die, the possible outcomes are 1, 2, 3, 4, 5, and 6. Die is the singular for dice. I have one die. I have two dice. Each outcome within this experiment is equally likely. So this experiment contains 6 different possible outcomes. Each outcome is equally likely. What is the probability of rolling a 1? Well, there is a 1 out of 6. The number of ways in which rolling a 1 may occur, only one way I can roll a 1, divided by the total number of possible outcomes. There's the total number of possible outcomes. There are 6 possible outcomes. What is the probability of rolling a 6? The probability of rolling a 6, maybe I should write this down in my notation. The probability of rolling a 6 is equal to, what is the number of ways in which a 6 may occur? Well, there's only one way in which a 6 may occur. Divided by the total number of possible outcomes, there are 6 possible outcomes. What's the probability of rolling a prime? So the probability of rolling a prime number, when I roll a die, is the number of ways a prime number may occur. Well, and if we look at the sample space, remember every outcome is equally likely in here. 2 is prime, 3 is prime, 4 is not, 5 is, 1 is not, 6 is not. So there are 3 different ways that I can roll a prime here. The number of possible outcomes is always 6, for a single die experiment, it's always 6. The number of ways I can roll a die is 3. 3 out of 6, that's a half. So if this die was rolled 60 times, how many times you'd expect the outcome to be a 1? We'd expect it to be a 1 1/6 of the time. So 10. I'd expect it to be 6. Well, it's the probability of 1/6, so we would expect that 1/6 of the time we will roll a 6, so we'd expect to get 10 6s on 60 rolls of a die. And the probability that I'd roll a prime, well, I would expect the probability to roll a prime is a half, so I would expect to get a prime on half of the rolls, so about 30. Important to note that that doesn't mean that every time you roll a die 60 times you'll get 10 1s and 10 6s and 30 primes. That's not necessarily the case, but that's what we would expect. And the more times you roll the die, the more accurate this kind of prediction process will be. Okay, let me look at another experiment. A letter is drawn at random from the word statistics. Find the probability that the letter is S. The probability that the letter is S equals. Well, let's have a look. I'm going to start with the number of possible outcomes. How many outcomes are possible? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 possible outcomes here. What's the probability the letter is S? Well, there are 1, 2, 3 S's in here. So there's a 3 in chance that when I choose a letter at random from the word statistics, that letter is S. What's the probability of a vowel? The probability of a vowel, well, again, there are 10 possible outcomes altogether. That goes on the bottom of the fraction. On the top of the number of ways in which the event may occur. The event here is a vowel. How many ways can I draw a vowel? Well, A is a vowel, I is a vowel, I is a vowel. There's 3 vowels in there. There's 3 ways I can draw a vowel. 3 out of 10. One thing to note, just to be careful about in this experiment, if I was to draw the sample space, it's the set of all possible outcomes. S is a possible outcome, so is T, so is A, so is I, so is C. And there are all the possible outcomes. In this case, each outcome is not equally likely. You know, for example, if I wanted to find the probability that I select C when I draw a letter at random, well, there's only one way that that can happen. There's 1 out of 10. So not all outcomes in my sample space here are equally likely. Look at one more experiment. One thing that's cropped up recently in class is that people don't know cards maybe as well as they used to. When I was a student, people played cards all the time. But I've noticed kind of more recently when I'm teaching that students don't really know all this detail about what's in a deck of cards. So a standard deck of cards contains 4 suits: hearts, diamonds, spades and clubs. Each suit contains 13 cards. Those cards are called Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen and King. So there are 13 cards in each suit. There's 4 suits. That's 52 cards altogether. And you got to know that because questions come up all the time in exams on decks of cards. So buy yourself a deck of cards, you know, practice playing a few things. Loads of card games out there. You don't have to be gambling to play cards. Loads of card games out there. So practice them. You play solitaire or something on your own, or patience, and you play cards with pals. Find the probability that the card is an ace. A card is drawn at random from a standard deck. Find the probability that the card is an ace. The probability that the card is an ace is equal to... I'm going to look at the bottom of the fraction first. Remember I said on the bottom of the fraction is the number of possible outcomes. So if I draw a card from the deck, how many possible outcomes are there? Well, there are 52. There's 52 cards in the deck. The number on top of the fraction is the number of ways that the event may occur. The event here is that the card is an ace. How many ways can I choose an ace? Well, there will be an ace of hearts, and there'll be an ace of diamonds, there'll be an ace of spades, and an ace of clubs. So that's 4 aces altogether. That's a 1 in 13 shot. So the probability that I draw an ace is 1/13. So I would guess that, you know, if I drew a card at random from a standard deck, and then I replaced it and then did it again, and then I replaced it and shuffled them and then did it again and replaced them and shuffled them and then did the same experiment over and over again, that about 1/13 of the time I would expect to get an ace. Find the probability that the card is red. So the probability that the card is red, again, the number of possible outcomes doesn't change. It's just a single card. How many red cards are there? What goes on top? The number of ways the event may occur goes on top. The event here is that the card is red. How many ways can that happen? Well, the red cards in a deck of cards are the hearts and the diamonds. The spades are black and the clubs are black. Okay, so hearts and diamonds, they're the red cards. Each suit contains 13 cards, so there's 13 hearts, 13 diamonds. So there's 26 ways the cards can be red. So it's 26 out of 52. It's a half. Which really makes sense. You know, half the cards are red, half the cards are black. Okay, so that's an experiment involving one task. In my next class, I'll look at an experiment involving more than one task. Okay? So practice.